So, hello everybody. I'm Julie, coming from the French-speaking part of Belgium, and this is my first online conference. So it's very special, and I would like to thank the organizer for this. So let's go. I'm here to present you some results of my PhD thesis, and as Rania said, I'm especially interested in the detection of understanding difficulties of novice students in programming. Then, the first steps in programming are known to be difficult. Then, sorry for my presentation, it doesn't work. It doesn't work. It's strange. I don't know how to change.
Try, Julie, to try to close it and reopen it.
Perhaps strange because perhaps it's too.
If you're trying to click on the actual Zoom, it won't work. You need to click on the PowerPoint itself.
Try to press escape or try to close it and to reopen your presentation.
I'm sorry, because yes, it's too strange. So I make it again.
This is okay, no stress. People are joining now, so it's fine delaying a couple of minutes.
Okay, like this. Like this, it's okay?
Try to share, press the share screen button.
Yes, but I think it's share, no? Yes, okay. Sorry. Like this, it's okay. I think. So, the first steps in programming are known to be difficult, and introductory programming course results in rather high failure and dropout rates. Then, among other factors, it appears that novice programmer, it doesn't work at all. Very strange. Oh, I'm sorry. Doesn't want to work.
What if you press escape?
Yes, like this.
And open your PowerPoint again. Don't put it full screen.
Ah, just a PowerPoint. Okay, okay. I think it's better like this.
The other thing you can do is to try your page down button. That may help.
Yeah, perhaps it's okay like this. I'm sorry. I just don't know why my computer.
We can't actually see your.
Yeah, we just see your email.
You can see your email.
So your screen sharing, yeah, that's right.
That's it.
So you can use this view, yes.
Okay. So I'm sorry. So I say that the first step in programming I know to be difficult, and that introductory programming courses results in rather high failure and dropout rates. Then, among other factors, it appears that novice programmers often hold misconceptions and use mental models that hinder their progress and may discourage them. These ones have to be identified for the teacher to be aware and to provide appropriate interventions. To detect misconception and mental models, we can use concept inventories. These research-based multiple-choice tests measure a student's knowledge of a set of concepts. The hypothesis is that understanding profiles can be identified among students enrolled in introductory programming courses, and that there is a direct relationship between the evolution of mental models and misconception and the evolution of students' understandings. So it seemed relevant to observe how this mental model and misconception evolve over a long period. We conduct a case study focusing on the VARIA programming concept over 2 years with 2 different groups of students following the same introductory programming courses. So the evolution of the understanding of 219 students was measured according to a specific methodology aiming to identify profiles among students. And also, the study aims to validate the assessment process used to identify these profiles. The reliability of this assessment is tested by determining with a test of significance whether the proportion of students falling into the identified profiles remains steady throughout the years. There is the composition of the students' sample characterized by the major, computer science or business engineering, and out of the 219 students, some students attended 4-hour summer classes. So it is in addition of the introductory programming course before this course. And this summer school class was devoted to programming. A concept inventory based on the 12-element concept inventory developed by Denadi was used and extended to 15 items. And as you can see, each answer to a question is related to 1 or more mental models defined by Denadi and to 1 or more misconceptions identified by solver. We conduct a study inspired by pre-test and post-test design, and data were collected 4 times each year with the same concept inventory during the period covered by the teaching of VARIA programming concepts, including the summer class. So you have 4 tests, the 0 test before the summer class, the test 1 after and before the class of the introductory programming course, test 2 between the class and the practical work, and test 3 after the practical work. It is the same concept inventory each time. We have 1 month between the 0 test and the test 1, 4 days between the test 1 and the test 2, and 3 days between the test 2 and the test 3. With this process, 9 profiles were defined by the shift moment from the use of incorrect mental models by students to the use of the correct mental model for each exercise. I invite you to read my paper for a detailed description of each profile because we have no time here. It's not so important for the paper, but all are described in the paper. Then we have here the result of the study. So you have the frequency distribution of students among the 9 profiles. And we excluded 2 profiles, the age profile, because this profile was not observed during the first year of the study, and the A' profile because there are students with prior knowledge in computer science, so it's not interesting in the framework of the study. And for the remaining 7 profiles, the frequencies may be equivalent from 1 academic year to another, according to the significance test. So the hypothesis is not rejected. After that, we presented the data collected and results obtained to 5 teachers and made interview with them. Just some results like this because it's a work in progress. So among 5 teachers, 4 are not aware of the existence of the mental models and misconception, and they realize with data the difficulties that their students may encounter during the courses. All are interested in students' profiling. One wants to describe mental models to their students to avoid incorrect ones, but one fears that students could adopt some incorrect mental models that they did not have before. And then so he prefers to use data as basis of a dialogue with each student. According to teachers, student profile should help to highlight student weaknesses and should help teachers to identify where to put effort in their courses. So while the revealing effect of assessment is no longer to be proven, its interest for teachers still needs to be clarified. It's a work in progress here. And the data obtained through these 5 interviews show that there is a room for discussion with teachers. In conclusion, during 2 years, I developed an assessment an assessment process, and I use it to provide 219 university students enrolled in an introductory programming course. I identified 9 profiles, and with a test of significance, I showed that the frequencies of students for 7 identified understanding profiles were not significantly different from one academic year to another. To confirm this result, the study was scheduled for 36 now. And a to-do list to continue the study. So the tests should help highlighting student weaknesses rather than highlighting when students understand. That's the moment now I can show to teach.